moving little bit faster here. Okay. Okay, and a flywheel is mounted on a vertical shaft. Okay, what we already seen is called an horizontal one. Okay, this is totally different. It's an horizontal one. So you want to find out that based on the L1 values. Okay, look it out here. This is an L1 value, it will be given, and the L2 value is given. Okay, so both based on that, you want to find out the Q1 value and Q2 value and summation of all this two. Okay, that's the thing as a vertical shaft. Okay, because that based on the length variation, the torsional stiffness is also varies there. Okay, so based on that, so you want to find out the Q1 and Q2, addition of Q1 and Q2, that's in summation of Q. Okay, and then I is in a same thing because of a single shaft. Okay, there is no material change here, so the mass moment of inertia will be the same there. Okay, and natural frequency equal to Fn equal to 1 by 2 pi square root of Q by I. Okay, these are the formulas. And next one is called a single torsional vibration of a single rotor system. Okay, first one is called single rotor. The one end is in a rotor and one end is called a fixed. The formula will be the same. Only one thing is called a rotor will be fixed in the shaft. What we already seen in the vertical shaft and horizontal shaft only. Okay, here is in a rotor. Okay, rotor means it will be rotate individually there. Okay, so that is called a single rotor system. Okay, same as like, and we move on to the second thing is called two rotor system. Here, in this a single rotor is one end will be in a fixed and one end will be rotating. Okay, and a two rotor system, both ends are rotating. Okay, I already given the example for this also. For this, a good example is called a motor and pump. Okay, shaft, one end is in a motor and another end is called a pump. It will be fixed. Okay, okay, and then this is called a node system diagram. And this is called a node. Okay, node diagram. Okay, this is called a node point, and this is a minimum maximum one, and then this is another maximum one. Okay, because it's in a cyclic process, you know that. Okay, it's in a cyclic process. Nodes. So the formulas for an node systems, and the terms it will be used, and the formulas. The main formula is called an Fn of A. Frequency of an A. Here frequency will be find out based on the rotors. Okay, so I taken as an Fn of A for the first formula. Okay, and Fn of B for the second formula, and Fn of A is equal to Fn of B because both the things it will be lying in the same shaft. Okay, so the frequency doesn't changes here. Okay, mass will be changes, radius of gyration, all these things will be vary. Okay, based on the application. Okay, but in the case of frequency, it doesn't changes because of this. It will be lays in the same frequency, same shaft. So same frequency it will be happen. So based on that, the formula will be written like this. So common terms are cut it down here. So LA into IA is equal to is nothing but of LB into IB. Therefore, LA equal to LB into IB divided by IA. Okay, and the general formula is nothing but of L is nothing but of LA plus LB. Total length of the shaft is nothing but of summation of A plus summation of A plus B. Okay, summation of A plus B of the length of the shaft. Okay, that's the thing. It will be given here equal to L equal to LA plus LB. These are the terms only we are regularly seeing. Okay, in the problems also. This formula. Okay, and this one and this one and this one. This is a general formula. Okay, but these two things are very necessarily we are seeing that. Okay. Okay, and this is called a three rotor system, and this is also we can see so many things. Free torsional vibration of the three rotor system. In a single shaft, three rotors will be rotating. For example, we can see a good example for this is called floor mills. Okay, rice mill or floor mills. Okay, all these things will be having in single shaft. There is a number of belts will be rotating. You can see watch in that floor mills, rice mills. We can see this kind of applications. Okay, in a single shaft they have been connected. Okay, in a tricycle also we can see these things. Two ends will be two tires will be there. In a center there's a braking systems will be there. Okay, tricycles. Okay, so that is also one of a good example for a three rotor system. Okay, so many areas will be there. Okay, and this is a node system. Node system for that. This is called a two node system. One node and two nodes will be there, and then again it will be a cyclic process. Okay, you want to find out that length of this only. This is called an LA, L1 minus LA, L2 minus LC, and LC. You want to find out this three lengths only in a node system diagram. Okay. Are you following? All of them following me? Okay. Okay, this is a frequency of an A, frequency of an A. Okay, and same formula 1 by 2 pi square root of Cj into La into Ia. Okay, and next one is called F1 of B. F1 of B, the formula only it's differ because the length of the shafts will be varying there. Okay, so for that only instead of an L, there is one small formula it will be instead here because of this L. Okay. Listen here, there LC is directly applying, LA is also directly applying. But in the case of LB, it will be like this. L1 minus of LA plus 1 by L2 minus of LC. But formulas are very important. Make a note of these formulas. Okay. It will be given in the book also. The same thing it will be given. Okay. Go through the book also. And FNC is in a general formula again. Okay. And FNC is nothing but a frequency of C equal to 1 by 2 pi square root of Cj into Cj divided by LC into IC. Okay. So LA is nothing but of LC into IC divided by IA, this formula. And this is also general formulas for that. And put together, we are using all the formulas for non-problems. Okay, and this is called what we seen already is called a 3-router system, 2-node system. Here is called a single node system. Only one node will be used. Okay, but this is called an actual node, and this is called a length of the first node. Okay, LA is different, and the actual node point is different. In some cases, some problems we want to find out the actual node values also, length of the shaft values, as well as in the actual node values also. Both the things we want to find out. Okay. And LC also same as like that. Vice versa, it will be varies. LA and LC based on the load conditions, it will be vary. LA will be smaller. Sometimes LC will be smaller. Okay, and both of the cases it will be possible. It's not in a it not lies in an exactly center point. Okay, it will be vary based on the conditions. Okay, load conditions and all those things it will be vary. And this is called A1, A2 and A3 formulas. And this is A1, A2 means this is the values. Okay, A1 and this is called an A2 and A3 values. Same as for the diagrams also. These are the things are not generally asking. Sometimes it will be asking about the length of the node also. Sorry, width of the node. Okay, length of the node you are finding out. Okay, LA, LC, all these things. L1, L2, LA, LB, LC, all these things. We can find it out. Okay, but in the case of A1, A2, A3, sometimes it will be asking. Okay, width of the node, that is called. And then it's called torsional equivalent shaft. All the shaft is not in the same throughout the length. Okay, so the diameter is not same. So we are here using that. The shaft is having that various sections. Okay, various diameters. Okay, D1, D2, D3 like that. So you want to convert it into like this. This diagram will be converted into like this. Okay, like a torsional equivalent shaft. Okay, like this diagram, you want to convert based on the from this diagram, it will be converted into like that. Okay, this diagram will be converted into like this. Okay, the step shaft will be converted into torsional equivalent shaft. For that, we are choosing that D1 as a major criteria here. Okay, we are choosing a D1 as a D here. Look it out in the diagram itself, it will be given. D is nothing but of D1. Okay, D1 it will be in this diagram. Okay, D means this diameter of the shaft. Okay, so D1 will be considered as a D. You are choosing the formula. Okay, we are equating the formulas. the same thing it will be given. So the formula will be rewritten like this, is called length of the equivalent shaft L equal to L1 plus L2 d1 by d2 to the power of 4 plus L3 d1 by d3 to the power of 4. Okay, these are the formulas we are using for the length of the equivalent shaft. And the problems will be based on that. Okay, we already seen these formulas. These problems. Yeah, this is a thing we want to see it now. A flywheel of an engine driving a dynamo has a mass of 200 kg and the radius of gyration will be given. Okay, and effective length is also given and the diameters, the armature mass, the radius of gyration for that, dynamo shaft diameter. So all these things will be given. Okay. So based on this, you want to find out that calculate the frequency of torsion and position of node. Okay. So all these things given in terms of centimeter, convert into meters. Same as like that. What we seen in a mm will be converted into meters there. So here also we are converted into centimeter into meters here. Okay. Centimeter into meters. Okay. Given a value is called centimeters here. So you want to convert it into meters here. So length of the equivalent shaft you are going to find out. So only one step will be that. So the formula will be changed. Okay, L1 plus L2 d1 by d2 to the power of 4. That's all. There is another step will be given, means you want to add plus L3 d1 by d3 to the power of 4. Okay. So based on that given data only you're going to change the formulas. Okay. Substituting all those things, you can get the LE value as 0.5912. 0.5912. Okay. That is the length of the equivalent shaft. Sir, length of the shaft இவ்வளவு பெருசா வருமா? இங்க 45 சென்டிமீட்டர் தான் கொடுத்துருக்கு, இங்க பாத்தீங்கன்னா 0.59 meters இருக்கு அப்படின்ற மாதிரி கேட்கல. Okay, it will be changes like that. Okay, based on the diameter it will be changes. Okay, 59 centimeter. Here total length is 45 centimeter. Okay, look at the diagram. In this we have 45 centimeter, it will be converted into 59.12. Taken as a d1 into d here. Okay, that is 5 centimeters, same as like this. Sir, கம்மியா தானே ஆகணும் அப்படின்லாம் கேட்கக்கூடாது. சார் இங்க திக்னஸ் கம்மியா, இங்க வந்து உங்களுக்கு டயமீட்டர் கம்மியா தானே இருக்கு, அது லென்த் ஆஃப் த ஈக்குவலன்ட் ஷாஃப்ட் கன்வெர்ட் பண்ணோம்னா உங்களுக்கு வந்து இந்த 45ஓட கீழே தானே வரணும் அப்படிலாம் சொல்லக்கூடாது. பிகாஸ் ஆஃப் வி கன்சிடர் அஸ் த த்ரூ அவுட் த லென்த். ஓகே, அந்த மாஸோட வேல்யூ, கேக்கான வேல்யூ எல்லாத்தையும் கன்சிடர் பண்ணி தான் நம்ம எல்லாம் பண்ணிட்டு இருக்கோம். ஓகே, and IA is nothing but of mk square. Okay, these are formulas, IA and IB formulas. So IA value is 18 meter square and IB value is 14.63 kg meter square. Sorry, here kg is missing here. Okay, so LA into IA is equal to LB into IB for the two rotor system. So you want to find out the LA value. LA is nothing, this same formula. LA is nothing but of LB into IB divided by IA. Okay, put the values, all these things. You know the IA value and IB value. Put it down here. So LA equal to 0.813 LB. 0.813 LA in terms of LB you are finding out. Okay. So total length of the shaft you already find out is 0.5912. Okay. That's the thing you put it here. So LE is nothing but of LA plus LB. This is also one formula. We seen in the two rotor system derivation itself. Okay, so LA equal to 0.813 LB plus LB equal to 0.592. So therefore LB equal to 0.3261 meters. So put the value in again in this equation, you get the value of LA. LA is equal to 0.2651. So 0.32 is LB, 0.26 is an LA value. Okay. So position of node of the actual system from the flywheel. Okay, this is a thing I already told that. Okay, position of node of the actual system la enga irukum அப்படின்றதை calculate பண்ணனும். Okay, this is a formula L1 plus LA minus LI d2 by d1 to the power of 4. This is a formula, is not an general formula. It will be vary. Okay, it will be vary for every system. மாறிட்டே இருக்கும் அது. Okay, இந்த formula இந்த சம்முக்காக மட்டும்தான். Okay. So L1 plus LA minus L1 D2 by D1 to the power of 4. Okay, put as things. So you get the value of 0.2588 meters. Okay, and natural frequency of the system. So you put on modulus J equal to 5 by 32 D1 to the power of 4 and frequency value. Frequency is equal to nothing but of frequency of A is equal to frequency of B. எதை எடுத்து போட்டாலும் சேம் தான். frequency of A எடுத்து சால்வ் பண்றோம் 1 by 2 pi CJ LA into IA சால்வ் பண்ணா get the value of 16.14. அதாவது கையில கால்குலேட்டர் வச்சிருந்தீங்கன்னா இதையும் செக் பண்ணி பாருங்க Fn of B எவ்வளவு வருதுன்ட்டு. Fn of B க்கு வேல்யூ சொல்றேன் நான் 1 by 2 pi square root of C கான வேல்யூ சேம், J is also சேம், I வந்து வேரி ஆகும், ஐயும் எல்லும் மட்டும் வேரி ஆகும். எவ்வளோன்றதை செக் பண்ணி சொல்லுங்க. Anybody is having the calculator with in your hand? You can solve it. Put all the values 1 by 2 pi square root of C into J, and instead of IA and LA I am giving another values. எடுத்துட்டீங்களா? யாராவது கேளுங்க, நான் சொல்றேன். LA value, IA value. Still 4 to 5 of them is missing. Always there is some lag of attendance in your class. Yeah, the same Arunachaleshwar, Balakarthik. All the students are missing. These are the regular students, regular absentee students. So just go through the sum once again. Anybody having calculator? Solve it and check it out whether Fn of A is equal to Fn of B. Okay, you can check it out. இருந்தீங்கன்னா செக் பண்ணிக்கோங்க, யாராவது கால்குலேட்டர் கையில் வச்சிருந்தீங்க. விமல் குமார் எடுத்து செக் பண்ணுமா, கொஞ்சம் செக் பண்ணி எனக்கு சொல்லுங்க. விமல் குமார், are you there in a line? சரி, செக் பண்ணி எனக்கு எவ்வளவு ஆன்சர் வருதுன்னு சொல்லுங்க. மைக் இல்லைன்னா என்ன? ஏன் மைக் இல்லை? எல்லார்கிட்டயும் ஹெட்போன் இருக்குது. காலேஜுக்கு வரும்போது எல்லாம் ஹெட்போன் போட்டு பாட்டு கேட்டுங்க தான் வரீங்க. பஸ்ல எல்லாரும் வச்சிருக்கீங்க, மைக் இல்லைன்றீங்க கேட்டா. நல்ல கதை சொல்றானுங்க பாரு. மைக்கு ப்ராப்ளம், பேசினா கேட்காது சார். Fn of A and Fn of B இது ரெண்டு சேமா வருதான்னு செக் பண்ணி சொல்லுங்க. யாராவது ஒருத்தர் சொல்லுங்க. சரி, விமல் குமார் மைக் இல்ல, வேற யாருக்குமே மைக் இல்லையா கையில? செக் பண்ணுங்க, இந்த இந்த லைனை செக் பண்ணி எனக்கு சொல்லுங்க. So just go through the sum. If you have any doubts, you can ask about the problem now. Sorry. And move on to the next slide. Just go through. What kind of a node system it will be given in the diagram? Anyone can give the answer. What type of a node system in this diagram? The third diagram it will be given in the screen. Okay, this one. What is the pointing out now? What type of a node system? இதெல்லாம் நல்லா ப்ராக்டிஸ் பண்ணீங்கன்னா உங்களுக்கு எம்சிக்யூல ஈஸியா அட்டென்ட் பண்ண முடியும். Single node, correct. Okay, next sum, we move on to the next sum. A single cylinder oil engine drives directly a centrifugal pump. Okay, the rotating mass of an engine, flywheel and the pump, the three rotors are shown in the figure. Okay, the mass moment of inertia is also given. Okay, find the natural frequency and modulus of rigidity. Okay, natural frequency மட்டும் கேக்குறாங்க அவ்வளவுதான். Okay, the given diagram is having the values L value and D value. Okay, frequency மட்டும் கேக்குறாங்க. Okay, find the natural frequency of the system. இதை நோட் பண்ணிக்கோங்க. இந்த சம்ம நாளைக்குள்ள எனக்கு சால்வ் பண்ணி காட்டுங்க. ஏதாவது சும்மா ஒரு சின்ன சம்ம தான் இது.
சார் பரணி சார்.
சரி சார். ஸோ ஓகே சார், நீங்கள் பேசுங்க.
சார் தம்பிங்களா, இப்போ ஒன்று நீங்கள் இந்த அசைன்மெண்ட்ஸ் வந்து நிறைய பேர் கொடுக்கல ராஜா. It's become as a very serious issue because remaining all set of the staff members are completely and they keep on receiving their assignments. You are very much interested to submit those assignments in the right time. But as far as this dynamic of machines concerned, you are not yet submitted your assignment. It seems out of 80, so far only 60 of them have submitted your respective DOM assignment. Remaining 20 of them, it seems that you are not yet taken any initiative towards writing of this assignment. So try to submit that assignment. As already told you, this 4 portfolios alone, it's going to play the major role. Your peoples are very much aware of that. Your class attendance, the marks which you are scoring in your MCQ, then similarly that assignment marks, as well as the following which we are planning to conduct the internal assessment test, because these are all the things will play the very good impact on your assignments. See, that's why we keep insisting your guys to just submit your assignment in the right time. Clear? Okay, I hope today you will submit your assignment in the right manner. See, because so far we have concluded with the 2 set of the brainstorming session. This time, this week, the question is that already you might have studied about the solid shaft and the hollow shaft and the application of the solid shaft and the hollow shaft in your day-to-day life mechanical system, as well as how the solid shaft is going to transmit the motion, that means rotating motion, as well as the hollow shaft is going to transmit the rotating motion. What is the exact application of both the things? You might have very much aware of that. You might have studied, perhaps you might have studied about the same things in your strength of materials as well. Okay, see, probably you might have attended the question that which shaft is the better one, whether the solid shaft is the better one or the hollow shaft is the better one. He used to write that sir, hollow shaft is the better one because it can transmit the much amount of the force as if as against compared with the solid shaft. This is the today's question. Okay, what is the technical phenomenon behind the top the solid shaft the hollow shaft, sorry, hollow shaft is better than the solid shaft. This is the today's question. Okay. See, it's, in front of you. Just I'm going to place one power slide. You can see that the J. Okay, the J value. What is the J value? Any one of them? You can unmute your mic and you can confront. You can say the answer for that notation of J. Krishna Kumar, are you there?
Yes, sir.
Yes, Krishna Kumar. What is J, Krishna Kumar? Krishna Kumar, can you
Sir.
able to hear me?
Yes, sir.
What is J, Krishna Kumar?
Polar moment.
Yeah,
Polar
polar
moment
moment
of
of inertia.
inertia.
Good, Krishna Kumar. You are coming out with the right answer. Polar moment of inertia. Okay. How the polar moment of inertia plays the major role in transmitting the motion as far as the solid shaft as well as the hollow shaft. This is the today's question. Okay. See, any one of them who understood the concept in the right manner in your early stage of studying of strength of materials, they can come out and you can feel free and you can say your answers now. Any one of them? Mr. Nirmal Gandhi K, are you there in line? Nirmal Gandhi, Yuvraj, Yuvraj K, Yuvanesh, you can unmute your instead of giving that answers in your chat box. You can just unmute your mic and you can just come with your answers. Just I would like to
Sir,
know how much of the understanding this
sir,
you have
polar
made
moment of
towards this.
inertia.
Yes, ma. Who
Sir,
is that?
polar moment. Jay Krishna, sir.
Yes, Ajay Krishna.
Sir, polar moment of inertia is an ability to oppose torsional moment, sir.
Its ability to oppose the torsional moment. Okay.
Uh, yes, sir. So when torsional moment is high,
Uh,
then the torsional when the polar moment of the body is high, polar moment of inertia of the body or the shaft is high,
uh,
its torsional resistance is high, sir.
uh.
So that's
The
why it
polar
plays a
moment
major
of
role in
inertia plays the vital role.
yes,
That's what you are coming to say now. Is it correct,
yes,
Jai
sir.
Krishna? When the polar moment of inertia value is high, you are saying that it would transmit the much amount of the torsional moment or torsional force. That's what you are coming to say. Is it correct?
No, sir. When polar moment of inertia is higher, torsional moment will be less, sir.
Torsional moment will be less, so
Less.
that the less amount of the weight can transmit the less moment of the weight upon the shaft can transmit the much amount of the force. That's what you are coming to say. Is it correct or
Yes,
not?
yes, sir.
Is there any other answer from your side? Because this is our third brainstorming session. Because as we already communicated to you, the prize winners. Okay, once our college reopens, already two set of the brainstorming session have been got over. the three persons so far just they have accrued their prices, they are deserved with their prices. This is the third session. Those who are all coming out with the exact answer, because I want the firm belief proof. Okay, just because Jai Krishna has come out with some set of answers. Because I want some sort of debate among your students. So no, sir. What he said is completely wrong. The answers which I am going to say is having the very the forbidden proof upon the answers which the Jai Krishna are going to say. Any other answer from your side, guys?
Sir,
Yes, ma. Who is that guy?
Vimal, sir.
Yes, Vimal. Yes.
Sir,
Good.
the moment of inertia of hollow shaft is lesser than solid shaft, sir. So it's
Vimal Kumar, and you are not audible, Vimal Kumar.
sir, polar moment
Yes.
of inertia of hollow shaft is lesser than solid shaft, sir.
Ah.
So it resists to rotate, but
Polar
hollow shaft
moment
can
of inertia of the hollow shaft is
lesser than solid shaft.
lesser
So
than.
solid shaft resists to rotate, sir, or twist.
Oh, that means the value
So
which you are going to attain by substituting that the numerical values in this particular formula, it's completely lesser than this one. That's what you are coming to say.
sir, solid shaft is lesser, sir.
Solid shaftல வந்து polar moment of inertia கம்மியா இருக்கும். Hollow
ஆமா
shaftல வந்து polar moment of inertia value வந்து ஜாஸ்தியா இருக்கும். When the polar moment of inertia value is quite higher, it can
சார்
transmit the.
ஹாலோ ஷாஃப்ட்ல தான் லெஸ்ஸா இருக்கும், சாலிட் ஷாஃப்ட்ல அதிகமா இருக்கும் சார் போலார் மொமெண்ட் ஆஃப் இனர்ஷியா. அதனால சாலிட் ஷாஃப்ட் வந்து ரொட்டேட் பண்ணது கொஞ்சம் கொஞ்சம் கம்மியா இருக்கும், லெஸ்ஸா ரொட்டேட் ஆகும். ஆனா ஹாலோ ஷாஃப்ட் வந்து ஈஸியா ட்விஸ்ட் பண்ணிடலாம். அது வந்து பவர் வந்து டிரான்ஸ்மிட் பண்ணும் கொஞ்சம் ஃபாஸ்டா.
பவர் வந்து ஈஸியா டிரான்ஸ்மிட் பண்ணும் ஹாலோ ஷாஃப்ட்.
ஆமா சார்.
சரி. See, both of them, yourself and Jai Krishna, both of them have somehow touched the same set of the concept again and again. But okay, whatever the answers which are said is somewhat correct. But still, I need more that conclusive answer, the precise answer. Is there any other student? நான் மறுபடியும் சொல்றேன், இந்த மாதிரி டிபேட்லாம் நீங்க பார்ட்டிசிபேட் பண்ணிக்கோங்க ராஜா. ஏன்னா நீங்க நாளைக்கு இண்டஸ்ட்ரிக்கெல்லாம் போன பிறகு this will play the major role, it will give the very good impact. நீங்க அங்க போயிட்டு if you keep your mouth shut and just you wait the others let to speak அப்படின்ற மாதிரி, if such a perspective if you are having in your mind, then automatically you will be thrown out from your company, ma. That's what again and again I am just communicating to your students. Just whenever we start with the debate, only 4 or 5 students are actually participating, just out of this 80. The remaining of them just like it. I do not know what to say, how to convince your peoples. I want everyone just to make utilize of this particular the forum. Yes, ma. Who is that guy?
Sarveshwaran, sir.
Yes, Sarveshwaran. Yes, ma.
Sir, hollow shaft is better than compared to solid shaft, sir.
Okay.
Because it carries large weight and torsion, sir.
Large weight. அப்ப solid shaft வந்து
Heavy
weight
weight.
கம்மியா இருக்கும்ன்றீங்க, hollow shaft வந்து weight ஜாஸ்தியா இருக்கும்ன்றீங்க இல்லையா?
Yes, sir. இல்ல சார், அது கேரி பண்ணும் சார். It can carry.
வெயிட்னு சொல்லக்கூடாது சர்வேஸ்வரன். நீங்க டார்க் இல்லையா, ட்விஸ்டிங் மூமெண்ட் ஆர் டார்க் எவ்வளவு டிரான்ஸ்மிட் பண்ணதுன்னா நம்ம பாக்குறோம் இல்லையா?
It carries more weight when compared to the solid shaft.
ஓகே. அப்போ சாலிட் ஷாஃப்ட் வந்து எப்படி சொல்றீங்க நீங்க? which one will have the highest weight?
மெட்டீரியலோட weight கேக்குறீங்களா சார்?
ஆமாமா. இப்போ சாலிட் ஷாஃப்ட் வந்து அதிகமான வெயிட்டா இருக்குமா, இல்லனா ஹாலோ ஷாஃப்ட் அதிகமான வெயிட்டா இருக்குமா?
சாலிட் ஷாஃப்ட் தான் சார் அதிகமான வெயிட்டா.
ஹாலோ ஷாஃப்ட் வெயிட் கம்மியா இருக்கும் இல்லையா?
எஸ் சார்.
அப்போ வெயிட் அதிகமா இருந்ததுன்னா அதுதானே அதிகமான ஃபோர்ஸ் கொடுக்கும். வெயிட் கம்மியா இருந்தா இப்போ நம்ம
இல்ல சார், இந்த ஹாலோ ஷாஃப்டோட ரேடியஸ் வந்து லார்ஜா இருக்கும் சார்.
சரி,
அதனால இட் கேன்
பார்த்துருப்பீங்க. இப்போ எல்லா இடத்துலயுமே வந்து இப்போ உங்க வீட்டுல காட் இருந்ததுன்னா கூட அந்த காட்ல வந்து பாத்தீங்கன்னா they will not use the solid shaft. Instead, normally they used to have the hollow shaft. I do not know how many of them have exactly noticed the such a visualization. சாலிட் ஷாஃப்ட் வந்து எங்கேயுமே வந்து பாத்தீங்கன்னா நீங்க இப்போ நீங்க ஈவன் இஃப் யூ கோ டு த ஜிம் இல்லையா, அங்க வந்து அந்த புல்லப்ஸ் எடுக்கும் போது வந்து பாத்தீங்கன்னா அந்த இடத்துல சாலிட் ஷாஃப்ட் போட மாட்டாங்க. நார்மலி தே யூஸ் டு ஹேவ் த ஹாலோ ஷாஃப்ட் இல்லையா? அதே மாதிரி உங்க வீட்டுல இருக்கிற காட்ல கூட வந்து பாத்தீங்கன்னா வாட் எவர் த டேபிள்ஸ் இல்லையா, இப்போ ட்ரெஸ்ஸிங் டேபிளா இருக்கட்டும், மெட்டாலிக் பார்ட்ஸ் என்னென்ன மாதிரி மெட்டாலிக் பார்ட்ஸ் இருக்கோ அது எல்லாத்துலயும் நார்மலி தே யூஸ் டு ஹேவ் த ஹாலோ ஷாஃப்ட். இது 3 mm thickness of the hollow shaft, 4 mm thickness of the hollow shaft தான் யூஸ் பண்ணுவாங்க. சாலிட் ஷாஃப்ட் அவங்க யூஸ் பண்றது கிடையாது. தட்ஸ் வாட் இஸ் அவர் டுடேஸ் क्वेश्चन. ஓகே
சார், அது பிகாஸ் சார் வந்து என்ன ஆகும்னா, இப்போ நம்ம சாலிட் ஷாஃப்டோட கேஸ் எடுத்துக்கிட்டோம்னா சார், இப்போ ஃபார் எக்ஸாம்பிள் இப்போ புல்லப் பாரே நீங்க எக்ஸாம்பிள் சொன்னதுனால சார், இப்போ புல்லப் பார் வந்து நம்ம சாலிட் ஷாஃப்டா வச்சோம்னா சார், இப்போ வந்து அப்பர் பாடி வந்து ஒரு ஸ்ட்ரெஸ், அதாவது அப்பர் பார்ட் ஆஃப் த சாலிட் ஷாஃப்ட் வந்து இப்போ டென்சைல் ஃபோர்ஸ் இல்ல கம்ப்ரெசிவ் ஃபோர்ஸ் ஆக்ட் ஆச்சுன்னா சார், ஆல் ஓவர் த பாடி அது ஆக்ட் ஆகும் சார். அந்த ஃபோர்ஸ் கம்ப்ளீட்டா ஆல் ஓவர் த பாடி அந்த ஃபோர்ஸ் ஆக்ட் ஆகும் சார்.
சரிமா.
ஆனா நீங்க சாலிட் ஷாஃப்ட் எடுத்துக்கிட்டீங்கன்னா only the upper part of the solid shaft will go more force rather compared to the bottom force sir. So அதனால பிரேக்
அதாவது அப்போ நீங்க என்ன சொல்றீங்கன்னா அந்த ஹாகிங் எஃபெக்ட்ல வந்து கம்ப்ரசிவ் ஃபோர்ஸ் ஆக்ட் ஆகும் சார், சாகிங் எஃபெக்ட்ல வந்து டென்சைல் ஃபோர்ஸ் ஆக்ட் ஆகும்.
எஸ் சார்.
அதனால வந்து it can withstand the much amount of the force அப்படின்னு you are coming to say.
அப்படிதான் சார். ஆமா. அண்ட் கம்பேரிட்டிவ்லி இப்போ நம்ம அப்பர் பார்ட்ல வந்து சாலிட் ஷாஃப்ட பொறுத்த வரைக்கும் அப்பர் பார்ட்ல எவ்வளவு ஃபோர்ஸ் அது எக்ஸாக்ட் ஆகுதோ இல்ல எவ்வளவு ரியாக்ஷன் தருதோ சார், டவுன் பாட்டம் பார்ட்ல வந்து இட் வில் பி லெஸ்ஸர் கம்பேர்ட் டு தி அப்பர் பார்ட். சோ அதனால இட் வித்ஸ்டாண்ட்ஸ் a lot because அந்த நடுவுல இருக்கிற ஹாலோ ஸ்பேஸ்னால சார். சோ அதனால அப்பர் பார்ட் ஆஃப் த பாடி அதனால அது ஈஸியா பிரேக் ஆகாது. பட் ஆனா சாலிட் ஷாஃப்ட் வந்து ஈஸியா பிரேக் ஆயிடும் சார். சோ அதனால சார்.
ஓகே 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 மா.
காஸ்ட் எஃபிஷியன்ட் சார்.
காஸ்ட் ஓகே. சரிமா, ஜஸ்ட் ஐ ஹேவ் because it's a very short span of time to just come out with the exact answer. I can understand the situation of your guys. Again in the coming week, okay, during our the session startup of brainstorming session 4, I would like to hear the answer and the phenomenal the explanations from all your guys. Okay, I'm expecting all the students to participate in this report with your exact answers. I hope I am very much thankful to the three of the guys who have actually participated in this particular forum. I'm expecting that even though your answers is somewhat correct, but as far as my perspective, it's not 100% correct. I need the precise and more technical answer rather than giving the colloquial type of the answers. Clear? I want to get the answer in the coming session. Clear? This is your question. Just prepare yourself and come out with the exact answer. Okay. Ma, next, the assignments வந்து இன்னும் வந்து பாத்தீங்கன்னா 10 to 12 students have not submitted your assignment. Ma, ஏன்னா deadline, see actually the deadline, the last week itself you have been given the clear instruction about your deadline. Before Saturday, you must have to submit the entire set of assignments because only 2 questions have been posted as the assignment. Okay, out of 80 so far only 64 of them are submitted. Remaining 16 people are yet to submit. So just today again I'm saying that it will have the very good impact and it will have the very good the scoring effect in your end of the semester. So that's why I'm pleasing to your students to come forward and take the initiative of writing this assignment and make sure that all of them have submitted your assignment before today evening. Clear? Then only that you will get the full marks. Otherwise, I'm completely sorry to say I'm completely helpless, guys. I'm completely helpless. Okay. Thank you, Ma. Thanks for your patient listening. With this, just we will wind up the today's session. Just we will look out the tomorrow session in the effective manner. Thank you, man. Thank you.